Hello and welcome to the Edupedia World. Well, this tutorial is part 3 of map interface, and in this tutorial we are going to concentrate on the internal implementation of map interface. So we have seen in our previous example how map does not allow duplicate keys, and while studying the set we have also seen that set internally uses map, and while calling set add method it actually calls internally map put method by passing its element in the key. But now how maps put method work and how map actually decides this key is duplicate or not, and how does it actually stores its element. Okay, so we'll see all that and understand the internal implementation of map in this video. So let's begin. Now we will see the actual implementation of HashMap, and we'll see how does HashMap actually works. Well, HashMap works on the principle of hashing. To understand hashing, we should first understand the three terms which are hash function, hash value, and bucket. Well, these three terms are really important to understand before implementing or before understanding the implementation of HashMap. So let's see what these three terms stands for. Now, what is hash function, hash value, and bucket? Well, the hashcode function which returns an integer value is the hash function. The important point to note that is this method is presented in the object class, which is also called as mother of all classes. Now this is a code for hash function, also known as the hashcode method in object class. So it's like private native int hashcode. So sorry, public native. So it's a public method which returns you the integer value. The most important point to note from the above line is hashcode method returns a int value. So the hash value is actually the int value returned by the hash function. So we have seen what is hash function and what is hash value. Now let's see what is bucket. Well, bucket is used to store the key value pairs. A bucket can have multiple key value pairs, and in HashMap, bucket use simple linked list to store the object. Okay, so it stores key value pair, and it could even store it in a linked list where it can store multiple key value pairs. Okay, so a linked list will, or a element of a linked list will have like one key, one value, and it does also have a hash value, and it then have a link to the next element. Okay, so it kind of have four things, each element of your linked list. Now this is a, you can see implementation of code for the get method. You can see it's a public method, it's returning UV, and it's taking object key. So what it does, it takes if key equals to null. Okay, then there is a hash code method. So there's some code, and the important code which you want to see is in line 4, where it calls the hashcode method on the key, and the value returned by this hashcode method, it's actually passed to the hash function. So this is a hash function defined in the map class. It passes the value of hashcode to that, and then this hash function returns a value which is stored in this int hash. Now, if the key is found in a hash table, that means we need to return that, otherwise null. Now, what happens once we get the hash? Then there is also another method which is index 4 method. Now, this hash is actually passed to that index 4 method along with the size of map. And once it is passed, both of the things are passed, we actually get the actual index, that is the bucket index of where it is actually stored. So once we get that bucket index, we know that is stored in this particular bucket, so we can easily fetch it. Let's say if that bucket is having a long linked list, then it has to travel through that linked list to find the its own actual key. Then it actually check for matching the key, and if it found that particular key in that linked list, it returns that element. Now, how HashMap works on the principle of hashing? Well, HashMap gets key, that is K key, And the method calls the hashcode method on the object of key and applies the returned hash value to its own static function to find the bucket location where key and value are stored in the form of a nested class called entry, which takes, a key and value pair. So if you have concluded that from previous line both key and value is stored in a bucket as a form of entry object, fine. Now whenever we call get method on a hash map, first it checks whether key is null or not. Okay. There can be also one null key in a hash map. If the key is null, then it's always stored in the index 0. So it simply returns the value from the index 0. If the key is not null, then we will call the hash function on the key as we have seen in the previous code in line 4, and it will call key.hashcode. So after the hashcode returns the hash value, the line 4 looks like something like this. And now it applies the return hash value in its own hash function. We might wonder that why we are calculating hash value again using a hash value. The answer is it defends against the poor quality of hash function, because it might be possible that the hashcode method you have overridden it yourself and you might have missed some cases or not overridden really well. Then the map's own hash function ensures that it does have a proper implementation and you get a unique value from the hash function. Now step 4, final hash value is used to find the bucket location at which the entry is stored. The entry object stores in bucket like, hash, key, value and bucket index. So there are 4 things which is stored in the bucket and the entry object. Fine. Now the solution, that is, what if you get like for two uh, what if you get, for two objects you get the same hash value, then what will happen? Well, the equal methods come to rescue. Now since bucket is 1 and we have two objects with the same hash code, then candidates usually forget that bucket is actually a simple linked list. Then bucket is a linked list effectively. It is not a linked list like java.util.linked list, but it's a separate, a simpler implementation just meant for map. So we traverse through this linked list, comparing the keys in each entries using keys.equal and until it returns true, and then corresponding entry object value is returned. This is how HashMap works. So this is a diagrammatical representation for the same. You see, like, these are bucket indexes 9, 10, 11, 12. So in the same way, we start from the 0 where we store the null key and its value if there is any, followed by 1, 2, 3 up till whatever the size of your hash map is. Okay, so this is just we have expanded. This screenshot is actually taken from the Eclipse Studio where we try to implement a hash map, and this is how it is actually implemented. So you see over here we are having on the 10th bucket, we are actually having this map entry. Okay, now this what all things this map entry is having. It's having a hash value which is 90. Fine. Then it is having a key. The value of key is country. Okay. And what does it contain? The actual value of key is actually Japan. Okay. It also contains its population, because country could be a class, user defined class. Now this user defined class can have another data members. So it might have name and population. Okay. So this is all this key contains. Then it also contains next. Next is actually pointing to the next element in the linked list. So if we go to this next, then what all this next will contain? Again, you see it's contain a hash. It contains a key which is country. Again, it contains a next. Now its next is null because it is not pointing to any other element. Then its value is Delhi. Okay, so this is one of a element in the linked list. You see there is one more thing, value. So this value is actually associated with this key, that is the outer one. So for Japan, the capital is given as Tokyo. Okay. Similarly, we have other elements also. So if two objects have same hash code, then they will be stored in a form of a linked list at one particular index. Okay. So now this is what the entry class looks like. The entry, then there's a country Japan and the value is Tokyo. In the next entry we have country India and the value is Delhi. Okay, so this is how it is stored in an entry object. The hash is also stored in the entry object, and obviously the name value and the next index is also stored in a entry index. Okay guys, so thank you very much. This was the third part. We have just one more part left to cover with map, in which we'll at least see what are different type of implementation of map and how do they differ from each other. So I hope so you have enjoyed this tutorial, and this was actually a really important tutorial. So it's important that you understand how HashMap is implemented internally. So okay guys, thank you very much. Let's meet in the next video.